Welcome everyone. In this video, I'm going to discuss about how we can solve the simultaneous differential equation by using the MATLAB. So I'm just taking the two simultaneous differential equations. So the first differential equation is say du by dt. The first differential equation is say du by dt is equal to minus 3u plus 2v. Is minus 3u plus 2v. This is the first differential equation, and the second differential equation is dv by dt is equal to 3u minus 4v. 3u minus 4v. These equations are called simultaneous differential equation because the solution of one differential equation will depend on the other one. Like here you see the solution of u is actually depending on v, and here solution of v is depending on u. So this kind of differential equation is called simultaneous differential equation. This is a first order differential equation. So in order to solve this equation, you need one initial condition, and say that initial condition for this is given like u, the value of u at t is equal to 0 is 0. Okay, and for this the initial condition is the value of v at t is equal to 0 was 0.5. Now you see, in the previous case we have discussed, we have only one differential equation. So we have one function, we have one initial condition, right? Here we have two differential equation, so we'll get two functions and we'll get two the two initial conditions. So by using the same the commands like ODE23 and ODE45, you can solve these differential equations. Now the only difference is here, instead of one boundary condition you have two, and instead of one function you have two functions. So only thing you need to see how you will actually write down these initial conditions and these functions. This is the only job you need to understand. Rest everything is same. So let's defining this. I'm writing this one is say I'm writing this is with the name u0. This I'm writing with the name say v0. Okay, this I'm writing with the name of u dot or u0. No, u0 is we have already written here. So it's up to you if you want to write some name, otherwise directly we can write something. I will explain in a minute. So here suppose you want the solution. At what point you want u0 is given to you, v0 is given. Okay, so initial conditions are given, or the functions are given. Now at what point you want the solution? Say you want the solution at time t, which is again between 0 to 10. Alright, so I'm just directly writing the program here. So as initially we have done, we have defined x0, right? So here you can define u0. You define u0 is 0, semicolon. Then you have v0, you write the value of v0 is 0.50, and then you write them together with the name say z0, and z0 you define like this, u0, and then use semicolon and write v0. You have to be very careful about the sequence, because you will see that in the coming section the sequence is very important. Accordingly it will do the calculation. It doesn't know about the u0 and v0 name, it just look at the sequence. This is u0 and v0 is for our convenience, right? So what we are saying here, first term we are writing for the u, and second term we are writing for the v. So z0 we have written. Next what we want the solution, and the solution at different time. So that we have written at different time like t span, and say the t span is again from 0 to 10. So we'll write 0 to 0 and 10. Next is the function. So we'll not write function here. We'll write the function in some another function file, and then we'll call it. So solution, you know how to write down the solution. You know the solution. You write t comma z, and then the solver, which solver you want to write. Say here I'm just writing OD45, so say OD45. After that I'll write the function name. So suppose that file is saved with the name that is a function file, so I'm writing fun underscore siml because it is a function file for the simultaneous function, so I'm giving the name this one. And if you want to call it, you can use either the @ symbol here, or simply you use a quote sign, whatever you feel you can use. @ symbol with this file name, I simply use a quote, and after that, you know, the sequence is for the tspan, so I'm writing tspan here, and then your initial values, so initial values are z0. This is the entire command. Suppose you have already written this function, then what it will do, it will basically tspan is related with this t. It will calculate the solution of u and the solution of v, and it will store in a variable named z column wise, and first column will correspond to u, solution of u, and the second column will correspond to the solution of v. So that is why it is very important to give the name in sequence wise. If you are giving the name, say the first initial condition for u and second for the initial condition of v, accordingly when we write down the function name, there will write the u and v. So it is going to, what is actually it is going to do in as a solution, when you solve it, it will store the solution of u and v in column wise, and the first column solution of z, first column, the first column will in the first column the solution of u at different time will be stored. In the second column of this variable z, the solution of v at different time will be stored. So how to, now the next job is to write down the function, and say I'm writing here the function. Here just I'm writing the function file, and so you know that any function file start with the name function, so I'm writing here the function. Okay, some variable name you write here, output variable, and then the file name, so I've written the file is fun underscore siml, simul, I think ml only, mul, okay, whatever the name you have written, simply write the name, and then input variable is of course x and t, and say your function is now is z dot. Okay, in z dot you are going to save the function. Okay, so you have two functions, right? You have two functions. So first you write down the first function, and first function, see, first you have written for the u. Okay, first you have you want the function u, so the initial condition for the first function written here. Now see what is the first function. First function is minus 3u plus 2v. So actually u is for the first column of z, v is for the second column of z, that is z2. So while writing this function, you will replace u with z1, you replaced v with z2, and simply write the function minus 3u plus 2v. So here you write minus 3u, instead of u you write z1, plus 2v, instead of, in place of v you write z2. So this is the first function. Now you come to the second function. Second function is for minus 3u plus 4v, 3u plus 4v, so you write 3u means z1, and plus 4, I hope it is plus, no it is minus, so whatever it is there you write minus 4v, minus 4 v, so write z2, right, z2, and close it, and the output is z dot. Now your function file is ready. I have mentioned that you should be very careful about the sequence. अगर आपने ये गलती ये कर दी कि say here you have written for the function for u and here you have written function for v, and while defining this z naught, you have first written the initial condition for v, and then you have written initial condition for u. It will not give you any error because it will assume that this whatever the condition is given is for the u. So whatever the condition you have given, the condition will swap, and accordingly it will do the calculation. It will not give you any error, right? So once you have written the file, now if you want to see the solution, simply you can write the plot command. If you want to see the solution of the u and v in a different file or in the same file, it is up to you. So suppose you want to see in the same file, you write t, and you want to see the first is for the u, so you write here z. First column, you want to see the first column. The first column this is for the first column of z, and if you want to represent them in a red color, you write red. And then if you want to see the solution of the v, you write like this, z colon 2. And if you want to see all together with the dashed line and in the color or whatever, you just give the command and you will see the solution of u and v all together. So I'm just going to write the same program here. So this is, let me write down the name. Let me write the name is this ODE for say simultaneous differential equation. So ODE SIML I'm writing, whatever you write. So this is for solution of simultaneous differential equation. So comment, and after that we have written the value of u0. So I think u0 you write, so u0 is 0.0 if I'm correct. v0 is, we have written 0.50, and then I have defined say z0. I'm writing the same line. Z0 is say u0 colon v0. So here we have defined the initial condition, and then we have to write the t-span. So t-span we want from 0 to 10, and then we need to write down the function. So that function will be written in the one function file. So we'll leave it for the time being, and we'll write down the next command. Next command is for the tz, and that is your ODE 45, and you write down the function name. Say the function is fun underscore SIML. Here I'm writing SIML. Okay, if you want to call it, you can call it by using this, writing like this, or by using the @ symbol. And then we write the first t-span, and then we write here z0. Okay, and after that, if you want to make a plot, you write here plot, and say you want to see this both solution in the same graph, you write like this, and say this should be with the solid line. First is with the solid line but with red color, and next is with the t comma, you write z, and in the second column it will store the solution for the v, and this you want to plot in the dashed line with blue color, say in the color dashed line. So dashed line, and say the blue color will write blue. But we need to also create this function file with the name fun underscore SIML. So let me write down this function file, this function output variable, function name fun underscore SIML, and then here the input variables are x and t. What is the output? I have stored the output with the name z dot, and let me see the function. First function was -3u plus 2v. -3u plus 2v means I'll write here -3u, so u is z1. Okay, and plus it is 2v, so 2 into v is z2. So the first function I have written here. The second function is 3u, so 3 into u, which is z1, and minus 4v, so 4, and then v is z2. So the function has also been defined here, and close this and write down the function name. It is z dot. So save it. Now just run this program. It is showing some error. What is that error? File name is same or not? f_siml. Let me see what is the error. Under define is it? Let me check. Where is file now? Maybe it is not calling the file. Call like this. I mentioned it should be t comma z. T comma z. T comma z. Now, yes. Now you see, you'll see one solution. With one solution, you have written in the red color and solid line, which is the solution of u, and you can also see it from here. When t is 0, the solution is 0, like u is equal to 0. Okay, and what is the value of v at t is equal to 0? It is 0.5. It is 0.5. So it is showing the solution. If you want to write down about the legend and all that, then you can easily add it. So this is all about how we can solve the if any simultaneous equation is given, how you can solve it. Similarly, you can also solve the more than two simultaneous equations. The only thing is you need to write down, all the initial values here, and the function in this fashion. Okay, so this is all about the solution of ordinary differential equation. In next lecture video, I will show you how you can solve the second order differential equation.